Morning. My name is Jordan Dolman. I'm a senior product manager on Amazon Web Services. I work specifically with our Amazon FSx for Lustre and Amazon File Cache services. I'm joined here today by Srinath Kirtikar, one of our principal solution architects within our file storage offerings. And today we're going to talk and do a little bit of a deep dive on accelerating HPC and machine learning workloads with Amazon FSx. So I'll just start by saying that customers use file storage pervasively. And one of the favorite parts of my job is working with our customers to provide storage solutions for a broad range of workloads. This includes storage and IT administrators who are running enterprise IT applications, user shares. It also includes builders, data scientists, computational biologists, researchers who are developing SaaS applications or running machine learning, model training workloads. And then for many of you, you act as both storage administrators and builders. And what we've found is that all of these workloads map to three primary use cases for file storage in the cloud. The first is running network-attached storage for a variety of applications in the cloud. The second is applications where customers are looking to leverage the cloud to unlock the virtually unlimited compute at scale. And finally, we have use cases where customers are trying to easily share data for cloud-native applications and workloads. And for the last few years, we've been razor-focused on working backwards from these use cases to develop storage offerings that meet the needs of these particular use cases. That includes Amazon FSx, which we purpose-built for network-attached NAS storage, as well as scale-out workloads. And we've done so in a cloudified way to take advantage of the best of the cloud, as well as the best of traditional network-attached storage. And Amazon EFS, which is our serverless, fully elastic file storage offering, which we designed for builders. In this session, we're going to focus on the second usage pattern. For running workloads with virtually unlimited compute scale, we're going to talk about how Amazon FSx delivers on that front and how it works. So what's driving users to run these kinds of workloads in the cloud? Well, it starts with finite compute capacity on premises. Finite compute capacity in their on-prem data centers or colos. And this creates a couple of challenges. The first is when a researcher, data scientist, anyone within an organization wants to run a workload, they can't always run it when they want to. They oftentimes have to schedule these workloads behind the work of their peers. Once it's scheduled, they also can't run it at the scale that they could potentially run it at in order to receive insights faster, get the results of their ideas quicker. In the cloud, it's a totally different game. You can get the capacity when you need it, and at the scale to respond to your users or to your customers quicker. And what we've heard from our customers who have moved to this model is that this isn't just about reducing the time to insight, the time to actually run their workloads and get a response back. It's actually changing fundamentally the culture within their organizations. That picture on the left, a world of fixed compute capacity, is a world where data scientists or researchers are actually competing with their peers for ideas to try to get in the queue faster and get the results of their insights, their experiments. In the world on the right, you can run small experiments when you want to. You don't have to make large capital expenditure investments and make big bets on some ideas that haven't yet been proven out. And so what we hear as kind of an unexpected result of moving to the cloud with these kinds of workloads is that our customers are working in a more innovative manner, more collaborative manner, and that the users who are actually running these workloads are even more engaged than ever because they get to test their ideas without having to compete with their peers. But compute is only a part of the story. Scalable compute requires scalable data access. And in an ideal world, it looks like this. The more compute you throw at a problem, the more data access you have available to support that compute and make sure it's fully utilized. In practice, that isn't always the case. And sometimes you end up with a storage bottleneck, a networking bottleneck. Your workload will still run, but you won't get the most value out of those compute resources, even if they're available in the cloud. And this is where our file storage offerings come in. We have two offerings for high-performance storage in the cloud. One is Amazon FSx for Lustre. The other is Amazon File Cache. Today, we're going to talk about Amazon FSx for Lustre. And for those of you who aren't yet moving your data to the cloud, but you want to take advantage of the virtually unlimited compute on AWS, you can still burst to the cloud using Amazon File Cache. And there's going to be a session on Wednesday to go deeper on how that one works. Both of these offerings are powered by Lustre, which is the world's most popular high-performance file system. It's used by the majority of the largest supercomputers in the world, by Frontier, Oak Ridge National Labs' largest and most powerful supercomputer available today. It offers highly scalable performance, it's POSIX compliant, and it scales to support hundreds of thousands of concurrent access. And what we've done with Lustre is we've fully managed it in the cloud. So this means that it's tested and operated at an unprecedented scale. Typically, the types of users who manage a Lustre file system have decades of experience, very much fixed in this domain of Lustre software. We're taking on the burden of that so that you get the access to the performance without having to deal with all of that knowledge transfer and maintaining a team of storage specialists. We also monitor all of the hardware that underpins our Lustre file systems. So if there's a hardware failure, we'll automatically detect it. We'll automatically replace servers or disks to make sure that your file system is operating in a healthy way. Of course, we have unified support along with the rest of our services. And we've also done the heavy lifting of trying to figure out how to build these Lustre file systems using the latest and greatest technologies at AWS, the latest and greatest technologies from the open source Lustre community, and make those available in the most price and performant optimized manner. We'll talk a little bit about the different options that you have to work with Lustre a little later in this presentation. I mentioned that we've also added a cloudified layer on Amazon FSx, so that includes a very simple and automated backup solution for your storage, and of course an API that allows you to configure and create Lustre file systems with infrastructure as code using a simple API call. As you would expect, FSx for Lustre is also integrated with a wide range of AWS services, all of your compute and orchestration services, Amazon SageMaker, and Amazon S3 as well. So who is running the kinds of workloads that benefit from something like Amazon FSx for Lustre? Well, it's really anyone who's spinning up a large number of compute instances, or EKS nodes, or ECS nodes. If you're spinning up a lot of compute, what all of these different industries and application areas have in common is they're spending a lot of money on compute, they're spinning up a lot of cores, they want to make sure that all of them are fully utilized. This looks different from one industry to the next. In the media and entertainment space, we're looking at visual effects rendering workloads and transcoding workloads. In the autonomous vehicle space, we're looking at customers who are trying to simulate their engine control units with simulation in the loop workloads, or running machine learning and object detection. In financial services, you have credit and risk modeling and all sorts of other analytics for trading workloads. And cutting across many of these are general high-performance workloads, machine learning, kind of industry-agnostic workloads as well. So let's go into what it is that Amazon FSx for Lustre is going to bring to your workloads, how that works, and then we can talk a little bit about some examples along the way. So the first is highly scalable throughput capacity. And so in this case, that means up to hundreds of gigabytes per second of throughput and millions of IOPS. So when you build an architecture that uses FSx for Lustre, you can have faith to know that it'll actually scale to meet your future performance needs. And this is really important because what we're seeing is EC2 instances with more and more network throughput. This is because models are becoming more complex, data sizes or the size of data sets are becoming larger, and to process that data, we need to move it quicker. So we need more network bandwidth. Now, in a traditional file system, you have an architecture that looks a little bit like this. You'll have on the left side a client instance, a server, and on the left side, right side, you have your single node file system. When you write a file to the file system, it goes from the client to the server to the disk. And when you read that file back, it goes the opposite direction. Pretty basic. Now let's look at how Lustre treats this same kind of operation. So with Lustre, if you have a group of files and you want to write those to your Lustre file system, the first thing you'll notice is that Lustre is built on many servers. This is how it gets its performance. Multiple disks, multiple servers, all pulled together. And when you write your files, they're actually automatically distributed across all these servers. When you read those files back, similarly, you're getting all the performance of all those disks, all of those servers, back to your client. And this is an oversimplified example where we are only showing one client. Of course, you could have thousands of clients simultaneously connected and all working with these same data sets concurrently. FSx for Lustre is architected in a way where when you add more storage, more disks, like you saw on the previous slide, we're adding more servers. And so performance is actually scaling with storage capacity. Larger file systems have more disks, more servers, more throughput, more IOPS. But the latencies stay the same. So let's see what this looks like from a scaling perspective. Because we offer a fully managed version of Lustre, and we have the ability to make updates to the file system after it's been created, you can create a very small single node Lustre file system. You can write your data to it. It all lands on the one set of disks on the one server. And then you can choose in the future to expand the storage capacity of the file system. In this case, we've added 2 additional servers. And behind the scenes, as a fully managed service, what we're going to go ahead and do is we're going to rebalance that data. We're going to take it from the older disks to the new disks so that you get the full performance of all of these resources after you've added the extra capacity to the file system. It's all happening under the hood transparently so that you get the full benefit not just of the extra disks, but of all of these resources together. Large files operate a little bit differently, but once again, we're trying to take advantage of the performance of all of these servers. So Lustre can automatically take large files, split them into multiple parts, and shard them again across all of the different servers and disks. So when you read one large file, you're still accessing the performance of all of these resources. Similarly, when you read the data back. We've had to make a lot of tough decisions when we tuned and built the Lustre file systems with Amazon FSx for Lustre. And we believe that for the majority of applications, we've tuned them so that you don't have to think about Lustre. You get this performance that we've been talking about without the expertise in Lustre, without having to figure out how to build it and maintain it on AWS. But there's always some knobs that you have available on your end if you want to run and tune your workload or your workload for the specific performance needs that you have. So I'll give you a quick example here. The way that we have deployed all of our Lustre file systems, any file that's smaller than 1 gigabyte will be stored on a single disk. Any file larger than a gigabyte is spread across 5 disks. Those are our defaults, and they'll work for the overwhelming majority of customer workloads. But occasionally, I see a customer who says, I'm working with 1 terabyte files. It's pretty big. Should I do anything different? And the answer is yes. You probably should do something different, and you can. So you have the ability to not take that 1 terabyte file and spread it across 5 disks, but to instead configure it, if you're working with a larger file system, to spread across n number of disks. You could spread it across your whole file system. You could increase this to maybe 8 or 16 disks. And the idea here is to get more performance so that if you're trying to read back that terabyte, again, you're getting the full performance of all of these servers and disks. It's configurable with a single command, and it's available on the client side without any other interaction with the service. On the results side, one of our customers, Rivian, moved to Amazon FSx for Lustre. This allowed them to debottleneck some of their high-performance workloads for simulation in the loop testing. They were able to achieve a 56% acceleration. Again, this is really about debottlenecking workloads at scale. We're thrilled to see those results. And we'll move forward now onto what this means on the price and performance side. So we have around 10 or so file system offerings within the FSx for Lustre service. We offer hard disk-based file systems. We offer solid-state disk file systems, hard disk with a solid-state disk cache, and unreplicated SSD-based file systems as well. It's a lot of different file system options. The reason why we did that is because we recognize that each of these technologies brings something different to the table. Hard disk technologies offer the lowest possible cost. Solid-state disk offerings offer the lowest latencies. And of course, if you're looking at replicated versus unreplicated, you're doubling the amount of storage, or at least adding a stretch factor into how much storage you have to provision to store your data. So this is what it looks like when you look at the pricing and the performance of all the different file system offerings. This is a sample of them, but you can see that on the lowest cost, we offer Lustre-based file systems at 2.5 cents per gigabyte per month, very similar to Amazon S3 standard pricing. On the high end, where we have a file system that's solid-state based, that has 1,000 megabytes per second of throughput, quite a bit of throughput, for every terabyte of storage, you can see we're up to 60 cents per gigabyte per month. And so when I look at this, there's 2 things that I think about. The first is high-performance storage doesn't have to be high cost. The raw cost of the storage can still be quite low if you look at like a hard disk-based deployment. The second is if you're looking to just get raw throughput, if you're just trying to make sure you don't starve any compute resources and you've got a lot of throughput needs, you need to move that data quickly. The densest throughput offering that we have is actually on the high end, our solid-state disk file systems, because those can actually stream throughput faster than our hard disks. And so you can see on this, the lowest cost on the throughput perspective is actually on our solid-state offering. On the theme of optimizing price and performance, we also have data compression built into our file systems. You can turn it on if you believe that your data sets are compressible, no additional cost, and you can see some sample results that I put together here. On SAS grid-based workloads, these are high-performance computing grid applications. a lot of ASCII text files, tremendous savings, 60 to 80% compression ratios that we're seeing there. For semiconductor EDA workloads, customers who are designing semiconductor chips and running simulations for their designs, we see around 50% compression. Healthcare and life sciences, there's a wide range of workloads in that space. Financial services. Once we start getting into weather and more imaging, you start to see that the compressibility is getting lower and lower because a lot of these files are already compressed. But this compression is available. It can help you make better use of your resources if you turn it on and your data sets are compressible. What's interesting about compression with FSx for Lustre is it uses an LZ4-based algorithm. If you're not familiar with LZ4, it's super efficient and super quick. I should actually say it's super quick and super efficient in the way that it's quick. It's not always going to give you the best compressibility, but it is going to make sure you don't have any adverse performance impact. So typically when customers think about turning on compression, they think that's going to add to latencies. It's going to slow down my throughput. What we've seen from our testing is that data compression doesn't actually introduce any latencies on our file systems, and it actually can provide a throughput boost. Let me show you how that works. This is one server node within our Lustre cluster. So you can see we've got a network interface card, the data comes in, we have cache storage, we compress the data on the server, and then we write it to disk. So all of this happens on the file system side. We're not consuming any of your compute resources to perform data compression. This particular server has around 640 megabytes per second of throughput or network bandwidth. And then to the disk, around 250 megabytes per second. If we turn on compression and we achieve a 2-to-1 compression ratio, the picture changes a little bit. The network throughput stays the same, but now our effective disk throughput doubles because we're moving the same amount of data to disk, but we're actually only consuming half of the storage and moving half of the number of bits. That 500 megabytes per second, if you're reading it from the disk, flows straight out through the front of that server and actually gives you a 2x increase in disk throughput. So really beneficial for any customers who are working with compressible data sets. Another area where we offer really great price performance benefits is on our backup storage. So this is something we built on top of our fully managed Lustre offering. If you take a backup of a Lustre file system, the first thing we'll do is look at all the blocks of data and store that off on S3, replicated across multiple availability zones. And then every time you take a backup, it's going to be incremental. We're going to look at the changes in the blocks since your last backup, and we're going to secure that up on S3. We're going to do that day after day, if that's the cadence you choose to take your backups. But the amount of data that we ultimately store is just the initial backup and any of the incremental changes. And of course, if your data is compressed, your backup data will be compressed as well. Customers like NXP, who work with FSx for Lustre to design their semiconductor chips, take advantage of these kinds of price performance benefits, getting the right level of throughput and the right latency for their workloads, using compression to minimize the amount of storage they use, and then taking advantage of backups, both for the compression and the incremental nature to get really cost-efficient backups of their data. Now we'll go to the third benefit that Amazon FSx for Lustre brings to your workloads, which is access to Amazon S3 data through a fast file interface. I think this is one of the most unexpected and really exciting capabilities that Amazon FSx for Lustre has had as part of its offering since day one. So let's explain a little bit about how this works. What we've found is that customers, since before we launched FSx for Lustre, have had a lot of their data in Amazon S3 data lakes. They've had data that's generated from an autonomous vehicle that's driving around collecting all sorts of measurements with its sensors, or cameras capturing all sorts of video imagery to be used in production as part of the creation of a new movie or TV show. And then, of course, sequencers creating all sorts of genomics data, all of these different data types ending up on Amazon S3 in an S3 data lake. But a lot of the workloads that actually process this data are file-based. Genomics is predominantly orchestrated with file-based applications. Media and entertainment workloads are predominantly file-based applications. And so the ability to connect all of this data to file system and then also have that file system be able to offer scalable performance has been incredibly valuable to our customers. Here's how it actually works. You can link Amazon FSx for Lustre to one or more S3 buckets. You can import all of the metadata, the objects in S3 onto the file system. And now you have a file system that looks just like your S3 bucket, that's mounted on your EC2 instances or your EKS or ECS nodes, and looks just like a local file system. The data sits on S3 until it's requested. So we can minimize the amount of data that's transferred and then lazy load it just in time for your application. If you make updates on S3, new samples come in from a sequencer or from your latest drive in your autonomous vehicle, those updates can be reflected on the file system seamlessly. And if you write to the file system, you create new files, you delete files, you edit files, all of those changes can be seamlessly exported back to S3 as well. Now, for some customers, they use FSx for Lustre as an always-on interface to S3. For other customers, they'll use this model for short periods of time while they're working with their compute instances. And when they're done, they tear down the file system along with their compute cluster. So they use it as short-lived, high-performance storage with seamless access to their S3 data. Now, there's, of course, some optimizations that come in when you're working with data movement. You can optimize for simplicity, where you connect your FSx for Lustre file system to your S3 bucket. You lazy load data as it's requested by your applications, and you export all of the changes that are made to any files back to S3 while you run your workload. It's easy, it's seamless, you don't have to give it too much thought. Half of my customers really love this model. The other half really are optimizing for performance at all times. And so what they're doing is they're preloading data. They want to make sure that they get the best latencies on every read operation. They don't want any data coming from S3 just in time. They want it coming from the Lustre file system with Lustre latencies and throughput when they're reading from the file system. They also don't want to disrupt or consume any bandwidth from the file system while they're running their workload. They want to create their compute nodes when the data is ready on the file system, run their workloads, destroy the compute instances, and then export the data back to their S3 buckets afterwards, and selectively export only certain files that are going to be needed for the future. So you have two options. They're both available to you with APIs and different policies that you can configure on the file system. Roche is another great example of a customer who is using this kind of S3 integration. I mentioned that a lot of customers in the healthcare and life sciences space who are creating a lot of genomic data are pushing that to their S3 buckets. We see the same thing with microscopes for cryo-electron microscopy. We see it with MRIs, all sorts of medical DICOM images. Healthcare and life sciences loves putting data on S3, and FSx for Lustre is a great way to get that data off and available with a file-based interface and performance that scales. So I've shown you a lot of slides to walk through how this works. What I'd like to do now is introduce Srinath to give you a little bit of demo into what this actually looks like when you're running FSx for Lustre with Amazon S3.
Hi, everyone. My name is Srinath Kodekar. I'm a principal solutions architect on the Amazon File Services team, and I focus on Amazon EFS and FSx. I'm going to do a live demo of how the Amazon S3 integration is going to work with FSx for Lustre. Jordan just walked us through, that with slides briefly. So this is my demo environment. I have an input bucket in US East 1 region, and I have an output bucket in US West 1 region. Think of it as a genomics pipeline, where my clients are uploading, genomic samples to my input bucket, and I want to process that data as fast as possible. I'll create an Amazon FSx for Lustre file system, link it to my input bucket in US East 1. I'll transparently import all the objects from my S3 bucket into my FSx file system, mount it from my compute instances, and leverage the scale-out performance of FSx for Lustre and process my data sets faster. Now let's say I want to write the data, the results of that analysis job to a different bucket. And that's what I'm going to do here, use my output bucket, because I want that data to be accessible to the users in a different region so that it's closer for them. Okay? Let's look at the demo in action here. As you can see, I have two buckets, an input bucket in US East 1 and an output bucket in US West 1. Right? So what I'm going to do is first walk you through how you can create a new FSx for Lustre file system, link it to a data repository, and how you can automatically configure import and export policies to automatically import objects from your S3 bucket into the FSx file system, and how you can automatically export changes from your FSx file system into the S3 bucket. So on my Amazon FSx console, when you click on Create File System, select Amazon FSx for Lustre, and click Next. Here you can specify a file system name. You select the deployment type. I'm going to leave it at the default. You select the throughput tier for your file system. I'm going to leave it at the default as well. I'm going to specify a storage capacity for my file system. And as you can see, the throughput capacity scale linearly based on the storage capacity that I specified for my file system. I'm going to enable compression to optimize for cost. Then under the Network and Security tab, I'm going to select my VPC, my security group, and my subnet. I'm going to enable encryption at rest, leave it at the default AWS managed encryption. And then under the data repository export import, this is where you will specify the association with your S3 repository. And this is optional. You can choose to create your file system and create data repositories at a later time, or you can associate a data repository at the time of file system creation. I'm going to select associating a data repository at the time of file system creation here. I specify a file system path. And this is the path under which the objects from my S3 bucket or prefix will be imported as files and directories in this directory on my file system. Under the data repository path, I specify my S3 bucket. I'm going to use my input bucket here. Next, you have the option to automatically import metadata from your S3 repository at the time of the data repository creation. If you unselect this checkbox, then we won't be automatically importing metadata for the objects from your S3 bucket into the FSx file system when the data repository is created. You can use a feature called as data repository task at a later point in time to automatically import the metadata and the data for your objects into the FSx file system. Next, you can configure the import auto export configuration. Here you can select how you want the objects from your S3 bucket to be automatically imported into your FSX file system. And you can fine-tune these configurations where you can select individual configurations or select all of them. So when you select new, anytime a new object is uploaded to your S3 bucket, it will be the metadata for that object will be transparently imported into the FSX file system. When you select changed, we update the file metadata on the FSX file system and invalidate the contents. So anytime you modify an object on your S3 bucket, that will be, the metadata for that will be automatically imported into the FSX file system. When you select deleted, anytime you delete an object on your S3 bucket, we will transparently delete that corresponding file on the FSX file system. And with these fine-grained controls, you have the flexibility to control whether you want to only work with new files, change files, or any deleted files as well. Next, you can configure the auto export policy, and here again you define how you want any new files, modified files, or deleted files on your FSX file system to be automatically exported to your linked S3 repository. So when you select new, any new files that are created on your FSX file system will be automatically exported to your linked S3 repository. When you change a file on your FSX file system, and if you have selected changed, it will automatically export that modified version of the file on your FSX file system and overwrite the content on your S3 bucket. And if you are deleting a file and you have selected the deleted option, then we'll delete the corresponding object on the S3 bucket. I'm going to just enable the auto import policy here, and then under logging, I'll leave this at the default. For the backup and maintenance, I'm going to again leave this at default and click next. And here we can review the data repository association configuration, where I've specified my input path, my S3 bucket, and I've set the auto import policy to new, changed, and deleted. Going to click on create file system. This will take a few minutes to create the file system. For the rest of the demo, I'm going to use an existing file system that I've already created. So this is a file system. As you can see, it's a 4.8 TB file system with data compression enabled, persistent to deployment type. And when I click on my data repository association here, you can see I have two data repository associations. The first one is to my input bucket, which has an import policy of new, changed, and deleted. And the second data repository association is to my output bucket, and I have the export policy set to new, changed, and deleted. So as I mentioned earlier, what I'm going to do here is simulate a genomics pipeline where I'm going to upload new files to my input bucket and write the results to my output bucket. Okay. And you can click on the data repository association ID to view the configurations, and you have the option to edit these configurations and change the auto import or auto export policies after the data repository is created as well. Okay. So now let's look at my input bucket here, and let me go through the S3 console here, show you the contents of my input bucket. As you can see, I have 4 files there, and my output bucket is currently empty. Let me connect to my EC2 instance. Just give me one moment. I just got disconnected from my VPN. All right. All right, now that we have overcome the VPN hiccup, I'm connected to my EC2 instance. Let's go ahead and mount the FSX file system. Right, so on my FSX console, I'm going to go ahead and click attach here, and I'm going to mount my FSX file system. Oops. As you can see, it's the 4.8 TB file system that I mounted on my EC2 instance. Now let's look at the contents of this file system. As you can see, I have the input and the output data repository paths that I had specified at the time of the data repository creation. Let's look at the contents of these paths. And you can see for my input path, I have the 4 files that were in my input S3 bucket, and my output path does not have any contents right now. So let's go ahead and read one of the files. Before that, let me show you the state of one of these files here. As you can see, when I do a HSM state on the file, it's showing the state as released exists archived. What this means is we have only imported the object and its metadata into the FSX file system, but we have not actually imported the data on the file system yet. We'll lazy load the data when the file is first accessed. And as Jordan mentioned, you have the option of preloading that content into the FSX if you don't want that first byte latency because of the lazy loading. Okay. So let me go ahead and read this file here. So what I'm going to do next is just time, the time taken to read this file. As you can see, it took about 4.4 seconds to read this file. Now let's look at the HSM state of this file. Now the state changed from released exists archived to exists archived. This means now the data has been imported into my FSX file system. So let me go ahead and clear the client-side cache and reread this file. Now that the file is on the FSX file system, I should be able to read this much faster. I've cleared the client-side cache, and I'm going to run the same dd command once more time. As you can see, it took less than a second to read this file. And you're now getting the high throughput sub-millisecond latency of the FSX file system. Right. Okay, so now let's go ahead and look at the auto import policy that we had configured for the input bucket, right? And I've configured the auto import policy as new, changed, and deleted. So what I'm going to do is I'm going to modify an existing file. I am going to add some new files and delete a file from my input bucket as well. Okay. So let me show you the contents of one of the file here. And I have a copy of this file on my local machine as well. As you can see, the contents are identical. Okay. Now let me go ahead and append some data to this file. Okay. And you can see I have 3 additional files here on my local machine as well. So now I'm going to go ahead and upload all these files. Okay. Okay, you can see it's uploading the files. Now if I do a ls in my input bucket, I can see the new files are already showing up in my input bucket. Now let me go back to my S3 bucket here and show you the contents of the S3 bucket. If I refresh the contents of my S3 bucket, you can see the new files were uploaded there, and they were automatically imported into my FSX file system. And keep in mind, we are only importing the metadata. It's only when you actually read the file, we'll be importing the data of those files into the FSX file system. Now let me go ahead and delete one of these files here. Okay, so I've deleted the 1 GB file, and as you can see, it's no longer in my S3 bucket. Now let's look at this, on my input bucket here, and the file has been, automatically deleted on the FSX file system as well. Right. Now let's look at, the output bucket that I created, and the output bucket. This is where I now have the files that I need to work with. I'm going to run my processing job and write some output files, and the output files will be automatically exported to my S3 bucket. Created some new files in my output bucket. If I list the contents of my output path, you can see I've created these new files. If I go to my S3 bucket, I should see these files showing up in my output bucket. As you can see, the new files that I created from my processing job have been automatically exported to my linked S3 repository. So you really get a lot of flexibility when working with RS3 integration, where you can fine-tune different configurations and configure automatic import and automatic export policy that allows you to tune these configurations for your different workflows. Right. Next, I'm going to switch to how customers are, using FSX for Lustre to accelerate their machine learning training jobs and optimize costs. Right. We typically see 2 usage patterns. The first usage pattern is where customers, host their data sets on FSX for Lustre and use FSX for Lustre as a high-performance file system for their machine learning training jobs. They really benefit from the scale-out performance of Lustre, the low latency and high IOPS, and are able to accelerate their machine learning training. The second usage pattern that we see is customers are hosting their data sets in S3, and they want the ability to accelerate their machine learning training for those data sets that are in S3. Right? And when your data sets are in S3, you your machine learning training instances need the ability to either download that data to the local EBS or instance store volumes, or they need to stream the data from S3 directly onto your training instances. Now think about, when you're working with large data sets, it could be, data sets comprising of millions of files or large terabyte-size data sets with, really large files. You spin up, this large cluster of, GPU-based or machine learning instances, and you literally are waiting for, downloading the data set for several days, right? I have worked with customers where they have terabyte-sized data sets, and they're just waiting for the data set to be downloaded for 2 days. And during this time, your compute resources are just sitting there idle, waiting for the data to be downloaded, right? Now, especially if you're using Spot instances, if your instances get terminated, now you need to restart this process all over again. You need to, restart the download of, the data set from your S3 into your into your EBS volume all over again. And what you see here is a case study that we did where we used the patient classification using liver data set. It's a 345 GB data set. And what we did was we benchmarked, the data loader time and the time to, load the data from your underlying storage into the GPU of your training instance, GPU or CPU of your training instance, depending on, the instance types. We benchmarked it with, both GPU-based as well as non-GPU-based instances, right? And we use SageMaker for this benchmarking. Now, SageMaker allows you to, use either file mode or fast file mode. With file mode, you can specify a file system like Amazon FSx for Lustre or EFS. Or you can, download the data set from S3 to your local EBS volume. Right. So when we did the training with the file mode, reading the data from S3, you can see the data set download time, can be longer. And then you have your training time as well, right? Now with FSx for Lustre, we totally eliminate that data set download time because you create your FSx for Lustre file system, link it to your S3 bucket. We already have those objects in the FSx file system, and you can start your training right away. So you're no longer waiting for, the data set to be downloaded, and you can kickstart, your machine learning training jobs right away. You also get the benefit of, the scale-out throughput of FSx for Lustre. And because of the scale-out performance, you can complete your epochs much faster. Now, what you see here in the second bar chart here is we no longer have that dataset download time. FSx totally eliminated that. And your training epoch is much faster because of the scale-out performance of FSx for Lustre. The first time when you run your first epoch, we are lazy loading the data from S3 into the FSx file system. So that's why, the overall training time was, slightly higher when we first ran the training. But when you run the training the second time, and you probably will do that, if you're doing hyperparameter tuning or you need to, rerun those training jobs, you can see now that the data is in FSx, the training was, much faster. Right. The other option where customers need to stream the data set, right? So they can use a fast file mode, or they can use things like web data set to stream the data directly from S3 onto the training instances. And what we have seen that it works really well for sequential data access patterns and for smaller data sets up to half a terabyte in size. So if you have data sets larger than half a terabyte, and if you're working with tens of GPU-based instances or machine learning instances, and your access patterns are random in nature, or if you're working with large number of small files, then FSx for Lustre is recommended solution for your machine learning training jobs, and you can really optimize it to accelerate your training jobs and also optimize for costs as well. This is a reference from one of our internal customers, Amazon Search. They work on enhancing user experience for products and services on Amazon.com. They train thousands of machine learning models concurrently, each with over 200 million parameters, right? And they have very large-scale terabyte-sized data sets. Their overall data set size is in petabytes, and they use S3 for its durability to store that data. But they wanted the ability to train their machine learning jobs faster. They wanted to increase the velocity of their machine learning training. And by using a combination of Amazon FSx for Lustre and AWS batch and EC2 instances, they are really able to scale their machine learning training jobs and concurrently run tens of thousands of these machine learning training jobs in a given month. So with that, I'll hand it over to Jordan for a wrap-up.
Thanks, Srinath. OK, so we covered a lot in this session. We talked about how scalable compute requires scalable data access. We talked about how high-performance storage doesn't have to be high cost. We walked through a demo that showed the integration that FSx for Lustre has with Amazon S3, how to get back into your VPN while on stage. Covered a lot of material here. And what I wanted to do is just spend a few minutes here if anyone has any questions, and then I'll stick around at the back for 30 minutes after the session if anyone wants to chat about their particular workloads. So in the interest of time, I'll kind of take additional questions at the back, but thank you so much for joining today, and have a great week with reInvent.